Hello, and welcome back to the Strange Water podcast. Thank you for joining us for another episode. Let's start with a very brief reminder of what a blockchain computer is. In the physical world, it is a network of real computers that are all running the same virtual machine, which is just a piece of software. All of these computers are in constant communication in order to guarantee that every single virtual machine is exactly in sync, using some sort of crypto economic system like proof of stake. Therefore, looking into the virtual machine on one of these computers is equivalent into looking into any of the virtual machines on any computer in the network. And each of these is an identical window into the virtual machine of the blockchain computer. So what happens when someone wants to interact with a blockchain computer? In the best case scenario, this person is operating one of these real-world computers. They would be able to pull up their local copy of the virtual machine, read the current state, and then send commands to change it. Any changes made locally would be synced to every other computer in the network. And likewise, any changes made on another computer in the network would be synced back to their local copy. We call these real-world computers that run the software that supports the blockchain nodes. And in an ideal world, all users of a specific blockchain would also operate their own node, giving them direct, permissionless access to the blockchain computer. But running your own node isn't always that simple. Let's just look at Ethereum. Today, running an Ethereum node requires a relatively modern computer, a constant power supply and internet connection, and north of a terabyte of bandwidth every month. And it's only going to get worse with EIP 4844 and danksharding. The reality is that running a node is just not accessible to a lot of people, even if they're interested in being node operators. But without a node, you cannot access the blockchain computer. And so, centralized RPC services arose. Services like Infura and Alchemy are simply just node operators who offer to relay requests and data back and forth between the blockchain and its users, so that users can access the blockchain without operating a node themselves. These services have invested an incredible amount of money to allow millions of people to use blockchain computers instantly and with zero direct costs. But the indirect costs are massive. As more and more users enter the crypto space without becoming node operators, a larger and larger portion of people access decentralized, trustless blockchain computers via centralized, trusted RPC services. And while incredibly effective, the concept of a centralized RPC service threatens the fundamental value proposition of blockchain computers themselves. But this is not a doom and gloom episode. In fact, it is very much an episode of hope and solutions. Today we have Gil Binder, co-founder and CTO of Lava Network, a protocol looking to take all of the paradigms and technologies we've built to create a decentralized blockchain computer and apply it to the RPC level. Over the next hour, you'll not only gain an appreciation of how RPC works and is changing for the better, you'll begin to realize that the modular blockchain revolution is about so much more than just execution versus settlement, rollups and data availability. It's about modularizing the entire world computer. One more thing before we begin. Please do not take financial advice from this or any podcast. Ethereum will change the world one day, but you can easily lose all of your money between now and then. Okay, enough of me. Let's talk to Gil. Gil, thank you so much for joining us on the Strange Water podcast.
Yeah, thanks for having me. A pleasure. Thank you.
Of course, of course. So I'm super excited to talk about Lava Network, and I think that just the whole realm of RPC is kind of the forgotten stepchild of blockchain computers and decentralization and all of that. So super, super excited to get there. But I'm a huge believer that the most important part of every conversation are the people in it. So with that as a preface, will you tell us a little bit about yourself, how you found computer science and crypto, and I guess why? What about it resonated with you so much that you decided to build a career in it?
Yeah, definitely, and thanks for having me. My background is a bit different from many crypto founders, I think. I'm originally from Israel, and I started, when I was a kid, programming in C and Visual Basic. But when I was recruited to the army when I was 18, I did 5 years at a top elite intelligence unit doing computers. So I gained a lot of knowledge there. And after I finished my service, I started a startup in cyber, and we were able to sell it in 3 years. It was very successful. Um, and when I finished doing that, basically I had like 10 years of experience doing reverse engineering. So looking at like really complex systems, like kernels, operating systems, browsers, JavaScript engines, stuff like that. And then like finding the flaws, finding the bugs, and seeing how things work with each other in the system. Sometimes even completely without access to the code. Um, and after doing that, I was looking into crypto from a friend, and he was saying, Gil, you have to come and see, what Ethereum is. And I was like, and this was only like 2.5 years, 3 years ago, so I'm pretty fresh, but I learned very quickly. So I was looking into Ethereum, and I thought that all of crypto was Bitcoin, right? I didn't know anything about it. But once I saw that, you have this Turing complete virtual machine that is basically executing a consensus across computers all over the world to reach, one state, I was like, whoa, this is pretty interesting. And my cyber mind was like, so that means that I can run code on every single machine that is executing Ethereum, which is like tens of thousands of machines. Like, okay, this is pretty interesting. I'm going to look into it. And basically from there, I wrote some MBV bots. I did some types of sniping and arbitrage and some NFT sniping for some drops, and it did pretty well until the space got congested. But at that point, I was like, okay, I'm in. I love this technology, what it brings to the world, and I think it's so early so that they can still like really innovate and bring something to the table.
So your background is like really hardcore cybersecurity. I mean, doing military stuff, like I can only imagine. But can you talk a little bit through this moment where your friends like you need to check out Ethereum? And I guess like was your first inclination, this is something that I need to penetrate, that I need to get into, that I need to reverse engineer, or was it like this is a platform that I can build upon? Like what was your first instinct when you saw Ethereum?
My first instinct was how can I take advantage of the system, and what is wrong with the system, and how can I, what are the flaws in the system. And the way I looked at it, what really triggered the interest for me is that my friend explained to me that in on Ethereum, there's only one state, and every block has a list of transactions, and every transaction is a function call. At that point, I didn't know anything. Yes, and then I was like, okay. And he said, if you execute a transaction, you can write a smart contract, and that smart contract can execute multiple trades for you. And those trades, if they're bad, then you can just revert. And if you're using like flashbots at the time, that transaction is not going to be included. So you never paid gas. So basically, you had a pure profit way to generate arbitrage. And I was like, he's bullshitting me. I don't believe that. It sounds, whatever. But then I went home, I went on vacation, and I had some time, and I picked up, started reading about the EVM, and dived into the Go Ethereum code. And then I was like, really? Oh, wow. Okay, so it is true. And I started seeing all these transactions, all these sandwich botters. At the time, we saw some people like abusing the actual botters. I think it was called Salmonella or Chum. I don't know if you're familiar with that.
I'm familiar with the efforts you're talking about. Yeah.
So basically, it was a smart contract that baited other botters to sandwich and give them salmonella by taking not basically completing the swap or giving them a small portion of the swap and on the transfer function. And I was like, whoa, this is really down, up my alley of doing reverse engineering, doing security and cyber, and this is really what drew me in. Only later on, it evolved into let's build on this, and now I understand the technology and what it brings.
And so, can you talk a little bit through maybe as a get us to Lava Network, but can you talk a little bit through why you entered this space like very much through kind of the MEV lens, or let me put it a different way, from your story, I could totally imagine you starting a startup that is about MEV, whether it's block building or part of the supply chain or whatever. And so can you talk a little bit through like what was the journey that led you leave like the nitty gritty dark forest and like enter up into this layer that is almost outside of Ethereum?
Yeah, okay, I think that's a great question. I was looking into, so I was doing the MEV and it was doing very well. And at some point, it became very, very competitive. So much so that I would have had to invest a lot of effort and time into maintaining the bots to be profitable because at some point they stopped being profitable. Also, the opportunities started to be more crowded. So at the time, for example, NFT drops, you need to have some kind of alpha and then to snipe them. But at that point, everybody was sniping them. Also, there were pools that were being established on chain for other people to put in and snipe these NFTs. So it was becoming so competitive that I was like, what else can I build upon to even get like and to build actually more technology and seeing that blockchain is not just MEV, right? There's so much more. There's like this primitive that gives you the ability to reason about logic in a way that's distributed and there's consensus. I thought it was really, really intriguing at the time. And my experience with, running these bots and, doing MEV was that I needed to have my own nodes. So I had like, a bunch of computers here and a pretty fast fiber connection. And, I was running all these nodes on these PCs locally so that I can get the fastest, latest data because that's crucial for blockchain data. And this is really what brought me to Lava. First, how difficult it was to maintain these nodes, kept updating, stopped working from some obscure reasons. You have to go to the GitHub and find out why. And then trying to scale it to many chains. Like, okay, Ethereum is crowded, let's go to, Avalanche. Avalanche is crowded, let's go to Polygon, right? Every single one of these, you need to run their own clients, their own nodes. And I was like, it's so fragmented. It's so difficult to do. So this is how the idea of Lava came. Let's just build a network that basically brings in people who are experts like me at running these nodes, right? And give them the ability to give service to users.
Yeah, I hear you. And I guess like just to close off the MEV part of the conversation, look, like obviously a lot of people like continue down that road and are making a lot of money from it. And that's not like a dead space, but I do think that there's a little bit of tea leaves to be read about where MEV is going and like whether we're talking about something like MEV burn or we're talking about like a bunch of different mechanisms that we're building to like smooth out MEV and then more just like bigger picture. Like what happens to MEV when the majority of transactions that are happening on mainnet are just like blobs and proofs, like ZK proofs. And so like I don't really know how much like reordering there is between blobs and if that's even possible. And so I do think whether or not this is what you were thinking, like it turned out to be the right pivot to just get away from like kind of the knife fight in the dark forest to like figure out how to look kind of, just more positive sum and more about how does the Ethereum transform into the world computer.
Yeah, so I'll just say I still do, I still have these cool projects from time to time. I see something cool and I build a bot. For example, French Tech, I was able to bot it and make really good returns and really bought really cool people on Twitter and then dump it. So it was a lot of fun. So I still do it from time to time, and I think there's still, and I don't need to think empirically. There's like a lot of MEV happening. It's just moved to different places. So it's still, but it's much harder to build. The competition is way more difficult, and you need a lot more capital to do it today.
Makes sense. So, queuing back into your story, I just want to, I guess, commend you, but also notice that history doesn't repeat, but it rhymes. And I was speaking to one of the advisors to Alchemy, and they were like, "Oh, do you know the story of Alchemy?" And I was like, "No, I don't." And he goes, "So what's very funny is this is back in the early days of Ethereum, and they were trying. I can't even remember. It was either some DeFi thing or some game or whatever, and they spent so much time just building like the RPC relay so that they could get the data they need to make their application that they realized like, oh my god." Let's just build a company around the amount of tooling we had to build. And it sounds like that is like a very similar experience to what you had.
It reminds me of Slack as well. You know, their story was very similar, where they were building something else, and they're like, "Well, we need a good tool to communicate inside the team," and they've built Slack. Like, wait, this tool is really awesome, and that became like obviously a major success.
So I guess before we get into Lava and decentralized RPC, let's start just with like a real brief explainer of what RPC is. And you don't have to go too basic. Like if you're listening to this show, you probably understand like the basic concepts. But why don't you just walk us through like we have the base Ethereum network. The Ethereum network is upheld by nodes, which can directly access into the EVM. Like, hopefully that makes sense to everyone. But like, what is this extra layer of RPC on top of it, and how do most users like use that to interact with Ethereum?
Yeah, so RPC is very simple. It's just a way to get data from the blockchain, right? So most users interact with it daily by going to their MetaMask or any wallet. When you see your account balance, that's RPC. How do you know the account balance? You query a server. That server is a node, and then nodes tell you it has access to the EVM state, as you've said, and it goes and brings the balance from the state to you. This is RPC in a gist. It's very simple. When you send a transaction, you send it to an RPC node, and it gossips about it to other nodes, and then it gets included in a block.
And I guess just to be real basic here, I thought the point of Ethereum was that we're able to interact with it directly and trustlessly. Like, why am I as a user have to go through this third party that is doing the trustless part for me, and then I'm trusting that third party?
That's an amazing question, and this is what I've asked myself ever since I got into this space. And I think, this is the Achilles heel of blockchain, right? Everyone is talking about this amazing technology, and then people are talking about Celestia, right? Data access, they're talking about dimension, building rollups, eigenlayer, restaking. All of these networks require access to data. And this is what Lava is. It's this layer that gives you access to all blockchain data. So why do they need to trust somebody? Because in the end, they're not going to run their own node because it's expensive. And as I've said, I'm an expert at doing stuff like that, and it was difficult for me. And I had to, have equipment to make sure it's fast and reliable. But no one's going to do it on their home computer. It doesn't make sense, especially if you think about adoption.
And I think one more thing that's worth pointing out here for like running your own node is 100% uptime is critical. And like, well, I'm not even referencing the fact that if you don't have 100% uptime and you're staking a crypto asset, that has implications for your P&L, let's say. What I'm talking about is if your node isn't like perfectly in sync with the rest of the network, then it needs to catch back up. And so, in order to be running a node, it basically needs to be running, not basically, it actually needs to be running 24/7. And so, the reason that you're not running it on your computer is because, like, I don't know, you're running a laptop. Like, you need to go to Starbucks. Like, you need to go to work. Like, you need to turn off your computer, or you need to let your kid play World of Warcraft on.
Yeah.
Sorry, people my age play World of Warcraft, not kids. But point is that like as of today, running a node requires dedicated Ethereum machinery, and like that's just not really viable for most people that like want to throw around a few bucks on base, right?
Yeah, and don't forget that if you're working on other chains, you also need to run those chains. So yeah, okay, let's say you're running Ethereum. Let's say you want to, go to Binance. Are you going to run a Binance Smart Chain, node that takes, hundreds of gigabytes to run and, weeks to sync? No. You want to trust somebody else to do it for you. So how do you do that without losing the values that are these, everything that we've, come to love in this space, which is, being permissionless, not having to trust anybody, knowing that the data is correct. And these are the questions we were asking ourselves. In addition to the fragmentation, how do we build a modular, piece that allows all of these chains, all of these rollups to give access to their users in a way that's not, just Web 2, like Facebook, right? In a way that's permissionless, trustless, scalable.
So let me walk through how a transaction works using a centralized RPC today. Then maybe you can correct me if I'm wrong, but then why don't you retell that story on how this works using the Lava network? So today, I open up my browser, I click MetaMask, and MetaMask has no information. So first what it does is say, okay, this is the address I need to check, so I need to go ask a centralized RPC, what is at this address? The centralized RPC says, this address has 1 ETH. Then MetaMask can say, okay, I know you have 1 ETH, and I know you want to spend half of an ETH, so I'm going to craft a transaction that does what you want it to do. I'm going to wait for your signature. And then once I get your signature, I'm going to send this back to the centralized RPC. And the centralized RPC says, this is a signed transaction. And so I can submit it on behalf of MetaMask to Ethereum. And then once Ethereum has it, hopefully we all know what happens. It's part of the trustless execution of the EVM and things are over. But the important thing to focus on is I'm not directly communicating with Ethereum. I'm using a centralized RPC to get my messages into the actual world computer. So first of all, is that correct?
That's correct on a high level. Yes, there's a few more details in there, right? But I think in overall, yes.
Okay, great. Well, why don't you walk through now, if you're using Lava RPC, how that works, and if any of those more details are relevant, just feel free to walk us through them.
Sure thing. So let's take as an example. Hopefully everybody should know. Uniswap, you want to do a Uniswap trade, right? So Uniswap has a contract on chain. It's called like the Uniswap router. And that contract knows how to make trades on the Uniswap contracts set, right? So when you go to their website, they have the definition of how to make a transaction for this, specific trade. And it's called, this data is called like ABI. And it defines the functions that exist on the chain. It's like a program. You said a world computer, it's like a program. Uniswap has a program, and the ABI defines how to call, like, what is it called? A swap. Let's call it swap, the swap function. So you call the swap function. You generate the data for the swap function, and then you send it to your wallet, and then the wallet has a private key. So you click sign, it signs it, and then broadcasts it to the RPC, right? And from then on, we've discussed that there's a gossip mechanism, or it's being sold to somebody for MEV, and then it gets to a block. Generally, that's how it works. In Lava, it works almost completely the same. The only difference is that we have something called the SDK, and this SDK basically has a list of many, many providers. Like Alchemy, like we talked about, like Infura, which is another big OG, RPC provider for Ethereum, and many more, right? So we basically have these providers. Some of them are actually on Lava, like Chainstack and BlockDaemon. They're actually staked on the Lava blockchain. They are staking tokens on the Lava blockchain, and this gives them access to give you service. So once they're staked, you are getting this list. This list has, let's say, 10 providers. We have something that basically talks to these providers on your end and finds the best one, the ones that's closest to you, the ones that is the fastest, the one that has the latest data. And then it takes that transaction and sends it to them, and then it gets to the blockchain. So very similar, the only difference is that first you're using the Lava protocol, which is Lava's superpower. It basically wraps the query. And the second is that you're talking to many providers at the same time.
So we'll stick with this number 10 just because it's easy. Let's say there's 10 providers in the Lava network. When I am sending a request to the Lava network, is that request being sent to a subset of the 10? Is it being sent to all of the 10? Is it being sent to just one? Like, how does that part of the process work?
Great question. So let's say there's 100, And the 10 is what we call the pairing list. Okay? So the pairing list is rotated every 30 minutes. So every 30 minutes you get a fresh 10. You might get the same ones, and the list is determined by how much money they've staked to give you service and what's their reputation, which is over time, how good was the quality of their service determined by you, the user. So over time, based on how much requests you've made, this will affect affects the quality of service of the provider, the reputation of the provider. So this is how they're choosing this list. So you go to every single one of these providers and you just probe them. You see who's the fastest, and then you ask them, give me your latest block. This is all done seamlessly in the background. So one tells you, I'm on block 100. One tells you, I'm on block 200. Okay, block 100 is done. This guy's out of sync. He's not 100% uptime. So you choose the best ones. There's an algorithm. It's a very complex algorithm that probes them and finds the best ones. And then you can talk to them and get the data or send the transactions.
So let's take a case where, like, super clear if one participant is saying we're on block 100 and another is saying block 200, like, obviously the first guy is just not caught up, right? But what about the case when both people say, this is block 200, but in this case, your account has 1 ETH, and in this case, your account has 0 ETH. How does Lava Network resolve that conflict?
So this is a different mechanism that we can talk about. But it's also really dependent on the actual blockchain that we're talking about. For example, on Ethereum, you don't have finality for like 15 minutes for your transactions, right? This is one of the things that Ethereum is working on to bring fast finality, like Cosmos. I think some other chains like Near have them, which basically means that you're sending a transaction, your transaction is confirmed. That doesn't mean that it's finalized. It means that there could be some kind of what is called reorg, and then your transaction will not be included. So, meaning the results of the transaction is not as you expected. So, for these types of chains, it's a little bit more complex, but in general, when you send a query over Lava, when you're like asking what's my account balance, optimistically, every once in a while, you send the same request with the same block number to another provider. Over time, if there's a difference between the two answers, this is what we call conflict. So this can happen from 2 reasons. One, or 3 reasons, I guess. One, there's a reorg, which is okay. It's not their fault. They're just seeing a different partition of the blockchain. They're thinking this is the right blockchain. The other reason is someone's lying to me. They're telling me I have no money. What the hell? And the third reason is like the second one, only they made a mistake. Okay, their server didn't work properly, there was a corruption, whatever. They gave me the wrong number. So for the malicious option and the corruption option, we basically have an on-chain consensus algorithm. This is where the Lava blockchain comes into the play. We so far spoke mostly on the actual protocol. This is the superpower. Again, the superpower of Lava is this protocol and the concept of specs, which we can touch on later. So you take these two responses. They are signed by the provider, because all communication in Lava is signed. You bring it on chain, and there's a vote on who's right. And whoever's wrong might get slashed or penalized in some way. So they don't want to get slashed. Obviously, this is why we have staking in Lava.
Yeah, no, and where I was trying to get is to understand how the Lava, like this is the wrong way to say this, but like the intersection between the Lava blockchain and then the Lava user experience, let's say. But I think maybe it makes sense to just like, let's quickly hop over to the Lava blockchain and then we'll bring this all together. So can you describe this a little bit, just like from almost like spec standpoint? Like what type of blockchain is it? Is it, an EVM fork? Is it, just can you describe like at the base layer, what is Lava blockchain?
Yeah, of course. So Lava blockchain is a Cosmos-based chain, meaning that it's built on Cosmos SDK and what used to be called Tendermint, now called Comet BFT consensus mechanism, which is a very tried and tested and true consensus algorithm and SDK. Very, very good. It means that it's a sovereign chain. It has its own validator set that validates the blocks. It also means that we have chosen actually to make it a lazy blockchain. It's not a very fast blockchain because it's not general purpose, right? It's not like Ethereum. It's not a world computer. It's more of like RPC, APIs, trustworthiness computer. It's very application specific.
And so what's happening on this main chain is one, just the proof of stake, which allows like everyone has to stake to join, and that gives you collateral to slash in case there's any problem. So there has to be this slashing mechanism. It sounds like all that's going on the Lava base chain is a slashing mechanism, which is the ability to take in reports from the individual participants, validate that against. Actually, I'll ask you, what are they validating that against? And then if there's a problem, then executing slashing. And that's all that's happening on Lava chain or the Lava blockchain, correct?
This is a bit more, and many, many, many thousands of lines of code, but I think it's a good way to portray it. The actual Lava blockchain. So when we started this, we were like, we want this to be fast. RPC, again, when you go to your wallet, you don't want to wait 20 minutes to see your balance. You don't want to wait, and don't forget, and just to let the listeners know, when you go to your wallet, it's making like tens, sometimes hundreds of RPC requests, every few seconds. It's not like one question, what's my balance? Like, what's my balance? What chain am I on? What's the latest block? What's the spot price of this pair? It's happening all the time. It's very crucial to understand that this is like the base layer, the base data access layer. So on the chain that we have, this is why we separated the protocol from the network. So the blockchain itself, as you've said, it handles conflicts of data. It handles payments, right? So these providers, they're joining to get paid. They're not doing it for free, right? So they submit proof of payments, proof of service on chain to get paid based on how much service they gave you. The chain also allows users to buy subscriptions on chain. So you are from your command line, you can come to Lava, buy a subscription, and never see any centralized website, and access using your private key. You can sign requests and send them to providers. So this is one of the cool features. Did I forget something? So quality of service, payments, conflicts. There's a few other things, but these are the core things.
And I guess let's talk through the payment side for a moment. So I think like what is a little difficult to wrap your head around is today, like we are paying for RPC, but it's one of those hidden costs. In the same way we're paying for Facebook, but we don't actually put our money out, right? And it's like the reason specifically MetaMask is willing to use Infura and no one's going to charge us for that is because they're made by the same company. And like there's this idea that ecosystem lock-in and the data that you can collect to build analytics off of the requests that are being made are worth it to the company that owns both these products. And I guess eventually we're either going to realize like we're all just going to be farmed for data and going to be okay with that, a la Facebook, or we're going to have to enter a new paradigm where it's you pay for your service and you get what you pay for. And so like that is essentially what you're describing here with Lava is like we're asking users to pay for this service, but in exchange I'm just going to guess this, tell me if I'm wrong.
Almost, we would never ask a user to pay, right? We would ask the developers or the ecosystem. I will definitely let me get into that. Who pays for service today and how it's going to work and how it works and how it will work in the future. But just remind me later to talk about specs because this is the part that I forgot that is huge in Lava blockchain, which is what makes it modular. This is what makes it part of the modular stack, the specs or the specifications. So think about who is paying for this service, who is bringing these users. It's very similar. I would say it varies between the type of blockchain. So Ethereum is a huge blockchain, right? It's number one blockchain, the most used blockchain, and the most robust and reliable and known blockchain, right? The Ethereum Foundation does not pay anybody to provide RPC for users. So who ends up paying for RPC? The people who want to capture the market and the audience of Ethereum. So, for example, as you've said, MetaMask, it pays, or I don't know if it pays, but it has an agreement with Infura, and they give them service. Uniswap probably pays somebody like Alchemy. They have a contract, and they pay a lot of money for the Uniswap users to get access to the data. Because besides the wallet, don't forget that the website or the dApp also needs RPC to show information on the website.
So I guess let me just take a pause here because there's basically like two ways to experience a dApp website, a dApp front end, right? One is you get on there, you see the little connect wallet button up in the top, but everything populates. You see all your APRs, you see all your TVLs, and that's what you're talking about. In that case, Uniswap is paying, let's say, Infura or Alchemy to populate all of those fields on your behalf. But we've also seen maybe some smaller projects or different projects that when you log on, it is completely blank. It's almost like the page didn't load until you hit Connect Wallet. And then when you hit Connect Wallet, all of the data loads. And in that case, the dApp is leveraging the fact that they know that MetaMask isn't getting charged for Infura, and basically it's not really worth walking through like how this like financial construction came up, but there is this important distinction where sometimes the dApp is directly paying the RPC provider, and sometimes the dApp is relying on the fact that they can assume that the user has a connection to the RPC and is going
I'll
to find
help
a way
you
to pay
out
for it.
with why and who pays what, because last year alone we spoke to like 1,000 projects. No joke. Uh, from dApps to ecosystems, etc. So wallets. If you need fast access, you're not going to use the wallet's RPC. There's only so much that you can use through the wallet's RPC. The wallet's RPC might be slow. It might not give you the fast access that you need to show real-time data or a lot of data. It might rate limit you. It's like a public RPC in a sense. This is why almost every production grade dApp that you'll use uses a separate RPC. All you need to do to check is right click, inspect page, go to console or network, and you can see that it's making queries to an RPC server. It's almost every production grade RPC dApp or service. So yeah, so again, if we go to Ethereum, this is one. So very well established blockchain. We have a few of those, right? We have Binance, we have Avalanche, etc. They will not pay usually for providers to provide RPC. So providers will come provide RPC, and the developers will come and pay for it because they need it. It's a necessity. Then you have chains that are up and coming, smaller ones. Like we work with a lot of these chains. They really need help with RPC because their users, they don't have anywhere to go and buy RPC. It doesn't exist, and if it exists, usually it's very expensive. So these ecosystems want to subsidize, just like MetaMask subsidizes access, or Infura subsidizes access for MetaMask. This ecosystem, they want to subsidize access to their RPC so that people can use it. This is what we call public RPC, right? And almost every blockchain has it. So this is the separation. We've been working with a lot of ecosystems. For example, we just launched what we call IPRPC. It's a really, really cool concept. I would love to get into it. But we launched it with Evmos successfully. We're launching it with Starknet. We've launched it with Near and many others. The concept is that the ecosystem basically pays Lava, but it doesn't pay Lava. It pays the market of providers. So let's say you are running nodes for Near. You can join the Lava network, provide service to end users, and get paid from the Near Foundation for providing that service. So this is basically the vision of the Lava network, where basically you have, and we have hundreds of providers actually on chain right now. We have from bespoke providers like ChainStack, BlockDemon, Blast, 01 node, all nodes, the list just goes on, to actually people who just run nodes. And some of them are really good, by the way. Some of them always rank at the top. They are, expert at DevOps and running nodes, and they run nodes for a lot of these chains. And only in the last few months, since we started IPRPC, the end of last year, with, I think, the foundation and the different ecosystem have distributed close to maybe $50,000 plus in tokens. And I think there are like hundreds of thousands more that will be distributed this year. Not making any promises, but as far as I know, there's a lot of contracts that are happening now. So it's really, really interesting and cool to see.
So in the long term vision of blockchain computers, do you think that the state that we have now, where all the RPC costs are like swallowed by the applications, whether they're the dApps or the wallets, do you think that's always what it's going to look like, or do you think that we will eventually move into a place where the option is run your own node, but because we have light clients and things are a lot easier, or you need to like have a subscription to an RPC? Like, do you think the cost will ever hit the end user directly?
No, never. I think it should never hit the user directly because it's all about user experience. In the end, we're building technologies that enable really cool stuff, but to bring adoption to the space, they need to be simple and easy to use. Just like Google doesn't charge you a subscription to use their servers, so doesn't Lava or anybody else to charge the end user for service. There's different models that allow for this. And one of the things that I'm thinking about in the future of blockchain is complete chain abstraction. I think, if you're bringing your grandma or, your uncle, whatever, and they want to use the blockchains, they don't care, they shouldn't care if it's Ethereum, Solana, Cosmos, if, what gas token they need to use, how much gas it's going to cost, what contract they're interacting with, what bridge they're using. All of these things, that's like asking, when I talk to my bank or when I go to Google, when I go to Facebook, is it HTTP, 1.1 or 2? Are they using, are they running PHP or are they running Python or Golang, or are they running it on Kubernetes or Lava, or they're running it on Apache servers? These things are the core technologies that we're building right now. And this is why I think the modular stack is really interesting. It's basically the bones that will be what's built on top of them is the user applications that will get the mass adoption. So this is how I see it.
And this is a little bit of a tangent, but I'll ask it anyway. I just want to cue in on what you said about like end game state of chain abstraction, because like in a certain sense I hear you. Like obviously UX for us is just like a mess, right? But taking a step back, right? Like if grandma was like, Rex, I want to buy ETH, and we lived in a chain abstracted world, and I was like, great, grandma, all you need to do is go on the Google portal and there's going to be all these routers and stuff, and then your account's going to say 1 ETH and then all's good, right? There is a like major difference if that ETH actually represents 1 ETH, not even wrapped ETH, but naked ETH on Ethereum, versus like a wormhole wrapped ETH on, or sorry, even better, Ronin wrapped ETH in the Axie universe, right? And so like I totally hear you that no one goes and checks which version of SSL certificates like are being posted, but
So maybe the question, right? Maybe the question is, and I don't want to get too high level. I think we have cool stuff to talk about. Maybe the question the grandma should ask is not where can I buy ETH? Maybe the question is, how can I order Uber on this app? And maybe Uber is a decentralized network that reaches consensus using all these amazing technologies we've been building. Or maybe she goes to eBay or Amazon and she's buying something for her house. And this is all done in a way that allows users to extract more value from the network versus big, huge enterprises, getting more revenues for the shareholders. Maybe it's a better way to create these types of big systems. Maybe, I don't know. But I think it could be interesting.
yeah, I hear you. And we won't spend any more time on this. The idea that like what chain you're on doesn't matter seems to like really go counter to what we're building, right? Because then why don't we just use AWS chain?
No, you still want to get all the values of what we're building, but you shouldn't care what the underlying technology is.
I think those are the same thing. I think that you can't have the values without the technology. And if you disagree, we'll just like ask well, I don't want to pick on anyone. Like ask Phantom, right? Ask people that have watched their chain melt down because of like decisions that they made in. Ask Luna. How about that?
I have no no comment on.
Anyway, let's bring it back to lava. And I think totally hear you. Asked and answered. Like the goal of all RPC systems is like never expose the direct cost to the users. That's just going to kill user experience. And
Yeah, but at the very minimum, let's agree that, right now it's a fragmented mess. And the more time that passes, we're getting more and more and more chains. And it's becoming more and more difficult, first for me, even, our user, to remember what wallets I have on which chain and what tools do I need to use on each chain to move my tokens or swap or, take a loan or make trades. So I think, and this is what we're building in Lava, right? We're building this network that allows, it's like another step of the modular stack. This is how we see it. You have, for example, Celestia or like Dimension, and on top of that you have Lava. Because every single rollup on Celestia or Dimension will requires RPC, requires that layer. And we are that layer. We're connecting all of them together. And then the next step is now think about our network. We have a huge number of providers for each one of these rollups. And these providers are staking tokens on the Lava network. So they're saying, listen, my data is accurate. You can trust me. Because if not, you can slash me on chain, right? There's so many things you can do with this primitive to prove to other people and other chains that the data that these providers are bringing on chain, if you want to, is correct. So this is how we see the vision and how we see Lava, part of the modular stack, whether it's on Cosmos or Celestia or Eigenlayer, but definitely this core piece. So this brings me to the specs concept that I wanted to talk about. So the spec concept is basically, and feel free to stop me, the spec concept is basically how do you define each chain, what data it can return to you. So it's like a menu at a restaurant, right? It's saying, oh, you can get, a salad or a soup or an entree. These definitions define the data that the RPC, the providers on the chain can give you as a user. What's my account balance? All those things are defined in that spec. So each chain has a lot of similarities, but also a lot of different types of specs. So in Lava, we have what we call champions. Champions are members of the market that basically build and maintain these specs. And for these chains, they basically champion the chain into Lava. And these specs allow us to dynamically observe what's happening inside of the actual queries. And this is the superpower I was talking about. So specs combined with the Lava protocol itself allows us to do really, really cool things. For example, we can talk about what we call validations. So let's say some contract is censored. Nobody is willing to give you access to that contract on chain. We know that exists. You can be a champion and you can bring a spec to Lava that says, if you want to be a provider for this spec, every provider is a provider for a spec, you have to give access to this contract. And this goes on chain. Now, when I'm talking to this provider, if it's censoring my query, I can take that answer, take it on chain, and slash it. So it's a way for us to actually make sure that there's no censoring happening for some contracts. One more thing that might be a bit more technical is what we call archive nodes. So everybody knows that, or I think a lot of people know that the blockchain takes a lot of storage to store, right? So the state, every block in a blockchain, the state changes, right? There's transactions change the state. But to store all the blocks, the state at each and every single one of every single block is very expensive. It requires, in some cases, tens of terabytes of storage. I don't know how much for Solana, but probably even more, right? So how do you incentivize people or companies or node runners to store this data and give it to you? But why do you need it? Because you want, for example, to know the price of a token over from the beginning of time, or you want to know the all the history of all the transactions of your wallet, something very basic. So how do you incentivize them to do it? So in Lava, this is what we've built. Basically, there's a way in the spec to define if you're giving me blocks that are 2 weeks old or more, you're gaining more rewards for providing them. So this incentive can be built into the spec system, incentivizing archive data.
So essentially what you're saying is the spec system not only allows you to like define the specific data or requests that you're willing to serve, but it also allows you to add the economic lever onto it and say like, okay, we want to incentivize this behavior, so we're going to pay more for it.
Exactly, yeah. And we want it. Everybody's asking us, when can we get archive data for this? When can we get archive data for that? And the only question is, how much are people, are companies or ecosystems or dApps are willing to pay to give that data to get the data?
And sorry, just on the censorship piece specifically, like the tough part about censorship and slashing is that it's really hard to produce proof that somebody didn't do something. So how do you work that through in like a automated slashing mechanism?
It's a great question, and we've built this mechanism from the ground up, not just for censorship, but for anything, any validation that you want to do. So one of the validations that we do right now on chain, for example, is you have to have 2 weeks of blocks available for the users for some chains. So basically, there's a validation. A validation is basically a query, like making a relay to the server, an RPC call, and you're asking the server, give me block from 2 weeks ago. And if you don't know how to answer it, then I ask somebody else, give me from 2 weeks ago. And then again, we have this conflict. If you don't know how to do it, we bring it on chain, and then you get splashed. There's a consensus, there's a vote. Everybody provides proof that they're able to capture the same result. And if it doesn't, and whoever side has the most votes based on stake, wins the debate on whether or not you provided bad information. For censorship, it works the same. For example, let's say you want to query a contract. What's my balance on this contract? You put this validation on chain. You ask two providers, what is the response? And as long as there is even one provider that is, honest, eventually you will get a conflict. You will go on chain, and you will see that it doesn't work. Also, there are constant validations that you could do. For example, you could ahead of time ask the contract, what is the response for this query? You take the response that is expected and you put it on chain. So now you only need to query the provider without any conflict from anybody else. The conflict is with the response on chain and the response from the provider. And this is, it's like a Swiss knife, right? So anybody can use it to build whatever spec they want and whatever validations they want. So these are all the options.
And I want to get to just like modularity in the modular blockchain like revolution in a moment, but while we're just like still very much on Lava and in this construction, the thing that I'm thinking about in a medium to long term roadmap standpoint is you're building a network of computers that are able to communicate cross chain, right? And then that is built on top of a network of capital that is like held by these computers that communicate cross chain. And so my question to you is like, as you're building this, how much long term does this construction start to look, and I don't mean to be reductive, in the best possible way, start to look like a bridge? And like, do you see the ability to expand what Lava Network is by also like not only being able to move data between chains and to users chain and vice versa, but also start to be able to move capital as well?
First, yes, you're onto me, okay? You're onto my vision, but wait, data is capital on blockchain. This is what's interesting, and this is why we love this space. The data is the actual capital. This is it. This is what's interesting about it. So yes, we're building a network of providers who stake and claim that the data is correct, and there's a mechanism to dispute it, and then others could potentially in the future rely on this data to build an interoperable network of blockchains, which is, again, going back to the vision and the modular stack is exactly how I see the future, at least.
So let's take the last 10 or so minutes here to talk about the modular vision. And the thing that is most frustrating to me right now in this narrative is that modular blockchain really just means like rollups and then maybe some data availability, and no one really knows what data availability means, right? But I am a huge believer in modular blockchains, not just that like we invented rollups, but in the idea that we figure out what's important to keep in the trustless space and we make sure that nothing ever touches that. And then everything that doesn't need to stay in that space, we pull it out and we find ways to make it faster and more efficient and better than could possibly happen within the EVM. And so, again, I'm frustrated because right now that means execution and data availability. And why I'm so excited to have this conversation is because the next obvious one is RPCs. And so I'd love to hear just like your reflections on like what the modular roadmap means, what it means to you. And if you're feeling really ambitious, like I'd love to hear if you have any thoughts on like what else is on the list of things that will be modularized and therefore will like supercharge Ethereum or blockchain computers into like really like the next level of capability.
I think, it's there's many ways to, I think it all comes to scale, right? Scalability. Because in the end, it's very hard to scale blockchains. Blockchains are these beasts that require consensus that is distributed over sometimes Turing complete logic. It's so difficult to do. So there are many ways to do it, right? We maybe touched on that before. But today we have a few models, right? We have Solana. So the trade-off is that you can, no, you have to be a professional node runner to run it because it's very resource intensive, but it allows for very fast data up to a point, right? There's also a limit there. You have the rollups on Ethereum, for example, where they store, it's like an optimistic proof, but you have one sequencer you have to trust. And sometimes the proof is not even yet, the optimistic proof or the fraud proof is not yet implemented. For example, OP Stack. I'm not sure how many people are familiar with that. It's on the roadmap. They're developing it. It's an amazing team, but it's not yet implemented on chain. Then you have the Cosmos version, which is like sovereign chains that serve in a specific application. So the modular stack for me means that you're going to be able to pick and choose the different parts that are relevant for your application to build the best application that can scale for your needs, to offer cheap gas, to scale to many users without crashing. All of these things are super important. So this is what modular means for me. The problem with modularity, which coming from a security background, I always look for where the most complex code is to find the bugs. Once you have many complex layers, there could be many integration bugs between them. When these pieces don't talk to each other correctly, this is when you can have a big fault. And because it's, the data is the money, the data is the capital, you can end up losing money, which is really bad. So these are the pros and cons, and I think over time, they will sort out all the bugs, and obviously, I do believe that modular is the way to go because it opens up so many possibilities. And the other thing that we didn't talk about is like restaking, right? So this is, I think, the next modular thing is like with the eigenlayer, just the ability to take the stake tokens and then use them to secure other chains, I think is insane. And it will be very awesome to see that live. So I'm really waiting for that.
Yeah, I mean, I agree. There's lots of insanity around eigenlayer, but I guess a good question to walk out on is in this modular blockchain in this modular blockchain world, like the biggest question mark to me is like every layer of modularity. implies like a new layer of 10 to 100 to a million, sorry, 10,000 to 100,000 to a million new computers running new software. And like, so now we have like distributed sequencers and then distributed DA layers, and that's on top of our distributed mainnet. And now we have distributed RPCs, and like the next layer of modularity that I have my eyes on is like based around zk SQL. So we're gonna have like modular distributed databases, like, but all of this is just more and more and more computers, and like we can barely get Ethereum to like break into the 5-digit number. So I guess like with your parting thoughts as someone who's building another decentralized network, how do you see the end game state of these distributed computing systems when there's only, in my head, there's a finite number of people willing to be like hardcore node operators?
So this is exactly why we've built Lava, right? We're incentivizing these node runners to provide this exact service that you're talking about. So I really like what you're saying, but think about the scale of even one company like Facebook or Google. The amount of compute that they use, I don't have numbers, I don't want to make up numbers, but if you exclude Bitcoin, obviously, how much compute do you think blockchain is doing in comparison to one of these giants? I would say it's probably close to nothing.
Yeah, 0.01% maybe.
Yeah, so this is just, and remember, this is just, it's a nascent field. It's like it's still like it's very very new, so very very early. And again, my view is that what we're building is like the core internet. It's like TCP/IP, HTTP, and then the first, Apache, PHP, what people used to use back in the day, right? So this is what we're still building. So I think there's enough compute to go around to run way more than what we're doing now, 100x, 1000x, and orders of magnitude. And when we'll see that, we'll know we have like true adoption of this space. And this is what I'm waiting for.
Awesome, man. Well, I think we can keep going, especially on this kind of more outer edge of the things that are coming. But for the sake of your schedule and everyone's attention, I think I'll cut us off here. So, Gil, thank you so much for the time. Now that I'm remembering, we didn't even get a chance to talk about your incredible news, your $15 million raise. So I guess walking us out a little bit, can you just tell us a little bit about that? And with that, how people can find Lava Network, how people can find you, and if they're interested in being an RPC provider, what are we in beta? Are we live? Like, what are the next steps?
Yeah, of course. So thank you. Yeah, we just announced our $50 million round, seed round from super OGs in the space like Tribe, Hashkey, Jump, and many 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 other supporters. So it's been very exciting. We've been developing Lava for 1.5 years now. We've been on testnet for the last year. And as I've said, we launched our first product about 3 months ago or 4 months ago with FMOS. We just launched with Near. You can become node providers and get rewarded for running nodes. Mainnet is coming soon. And yesterday we announced what we call Magma. The foundation, basically, Lava Foundation launched a points program that I think it's the first of its kind to try to incentivize people to use different RPCs. So if you switch over, go to the points.lavanet.xyz, switch to the Lava RPC, you can start accumulating points, which I think is really, really cool in the space. Yeah, find us on Twitter, find us on our website, and yeah, it's been really, really great. Thank you.
Awesome, man. Gil, well, again, congratulations both on, of course, the raise and like the big things that this means for Lava, but really, in a bigger sense, congratulations on like really understanding one of the true centralization and like risk points that we have in this space and like doing something to solve it. And I think that you could have very easily stuck in MEV, or you could have very easily become like a shitcoin trader or anything that is really about value extraction. And instead you found something that's about positive sum and about like bringing the future closer to us. So just want to say thank you. And I'm so excited for you. And yeah, man, just have a good day.
Thank you, man. Have a good day too.